What's poppin', dogs? Mr. Allen here with a couple triangles where we got to solve for a missing length. And these actually involve some properties of similarity. So in this first one here, I've got AB is 10 whatever, units, feet, inches, I don't know. AC is 14, and then DC is 8. Now I got to solve for X. So how the heck do I do that? I mean, if I was given the perimeter, I could add them all up and subtract, but I don't have that. What in the heck is up with these two angles here? Do they have any significance to the problem? Well, yeah, these two angles are congruent. And if these two angles are congruent, or if AD, in other words, is bisecting this angle, it splits this triangle proportionally. And what we mean by that is that I can actually set up a proportion with these side lengths. You can either go across 10 over 14, I'll write that down, 10 over 14 equals X over 8, or you could go from left to right. You could do 10 over X equals 14 over 8. But you cannot go around or diagonal and have this work out. One thing that you'll notice about these two different proportions is when we cross multiply, 10 is still getting multiplied to 8 for both. X and 14 still getting multiplied, okay? So however you want to set it up and solve is up to you between these two here. But remember, it's either across from each other like this, or so like up and down, or left to right, left to right. But don't go around, don't crisscross, okay? Cool. So now what I'm going to do is I'll just work with this one right here. We could simplify beforehand if we'd like. You can bring the, let's see here, the 10 and the 14. That would reduce down to, let's see here, that'd be 5 and 7. Okay, that helps a little bit, I guess. So now I would have 5 times 8 is 40 equals 7x. Divide by 7. That's not going to simplify it. Also, we'll just say x equals 40 over 7. Woo! How exciting, right? So exciting. It's absolutely fantastic. All right, if we want to get like a decimal for that, let me pop out my calculator here real quick. 40 divided by 7, that's about 5, so approximately 5.714. 5.7. Cool. So if they ask for a decimal, you could still do that. All right, dope. Next one here. So we've got a slightly different setup. I don't have any angles marked, but hold up. It does say AD bisects angle CAB. So let's go ahead and mark that in here. These two angles are congruent. So it does, once again, split this triangle proportionally like we were talking about. Let's label some sides here. I've got CB is 20. The whole thing's 20. CD is 8. Okay, hold up. So this whole thing here is 20. Could I do 20 minus 8 to equal 12? That'd be that guy right there, right? So we want the individual sides. So a little bit of subtraction, you know, a little math right there within the math. It's exciting. And then AB is 16. All right, let's go ahead and set this thing up. So again, we can go left to right, or we can go top to bottom, top to bottom. I'll go top to bottom on this one. We got x over 8 equals 16, over 12. I'll reduce this because these numbers are going to get kind of large here. We can divide those by 4, right? This would become 4 over 3 then. Much more manageable. So now I've got 3x equals 32. And once again, we have just this, you know, ugly fraction as our final answer. 32 over 3. So that'd be what, like 10 and 2/3, 10.6 repeating would be another option there. Cool. All right. How do we get 10.6 repeating? Well, 3 goes into 30 10 times. With 2 left over, 2/3 is 0.6 repeating. So there we go. It's a small equal sign. It might be kind of confusing. I don't know if that's any better. All right. There we go, guys. So cool little property similarity there with the bisecting of the angles that sets up this proportionality between your sides of these two triangles that are then formed. Dope stuff. Super fun and awesome. Just like you guys. And have a great day.